Hello, everyone, and welcome to Khan Cloud Academy. I am your host, Shoaim Khan, and I'm thrilled to have you here. Whether you are seasoned tech enthusiast or just dipping your toes into the digital world, you have come to the right place. So let me talk about a little bit about my channel. So at Khan Cloud Academy, our mission is simple to empower you with the knowledge and tools you need to navigate the ever evolving landscape of technology. From in-depth tutorials and troubleshooting guides to the latest product reviews and in the industry insight, we have got you covered, right? So so detailed tutorial on this, I'm going to discuss on Terraform and Terraform, how we develop our, the IAC coding, which language is using, and the techniques. So a step-by-step guide to setting up and optimizing your, code on the various cloud. So in-depth reviews and comparison of the latest, you can say the updates from, industry apart and how, everyone is using right now. Okay. So I will going to also explain in videos, this is all about, Terraform tools and technology, right? So whether you are looking to master a new skill or solve a tech related problem or stay up to date with the latest trend, so can you please hit the subscribe button and join our growing community of tech enthusiasts. So thank you for your turning to into Khan Cloud Academy. Together, let's unlock the endless possibilities of technology. Right. So let's start. Uh, on the Terraform. So welcome again, guys, and let's move to the next slide. So this is what is infrastructure as a code with the Terraform. So Terraform is an infrastructure as a code tools that lets you build, change, and versions cloud and on-premises resources safely and efficiently. Right. So move to the next slide. So what is the benefit of Terraform? So HashiCorp is the is a company who have on this Terraform tool. So Terraform is an infrastructure as a code tool that lets you define both cloud and on-premises resources in human readable configuration files that you can version, reuse, and share. So you can then use a consistent workflow to provision and manage all of your infrastructure throughout its life cycle. Terraform can manage low-level components like compute storage and networking resources, as well as high-level component like DNS entries and SES features as well. So after that, you are able to try on hands-on, like you can start managing infrastructure on popular cloud provider like Amazon Web Services, Azure Cloud, Google Cloud Platform, Oracle Cloud Infrastructure, and Docker and Kubernetes as well. So Terraform creates and manages resources on cloud platform and other services through the application programming interfaces APIs. Providers enables Terraform to work with virtually any platform or service within accessible APIs, right? So how does Terraform work? So Terraform basically ISC code, you can say infrastructure code tools, and it will a Terraform provider, AWS, Azure, or anyone, and you have to target the target API. The core Terraform workflow consists of three stages. Number one is write, plan, and apply. Third one is, so what is write? You have to define resources which may be across multiple cloud providers and services. For example, if we might create a configuration to deploy an application on virtual machines in a virtual private cloud VPC network with security groups on a load balancer. What the plan Terraform creates any execution plan describing the infrastructure it will create, update, or destroy based on the existing infrastructure and your configuration. So plan is very important in the Terraform. So whenever what you're going to deploy, it will show you actually. This is what is going to be deploy after you apply the command. So apply means it's kind of an approval which executor run the code, and after the approval it will deploy the same thing on the whatever the service provider you have. So Terraform performs the proposed operations in the correct order, respecting any resource dependencies. For example, if you update the properties of a VPC and change the number of virtual machines in that VPC, Terraform will recreate the VPC before scaling the virtual machine, right? So why Terraform? So Terraform basically write, plan, and apply. As you seen here, define the first in a configuration file and Terraform configuration, whatever the project you are going to create. So Terraform also maintain a Terraform state file. We will talk about very detail in the Terraform state file. Plan. So planning means Terraform will perform the following actions and apply. Whenever you apply, whatever your service provider will go and deploy the services. So Terraform basically manage any infrastructure. You can track your infrastructure very efficiently, automate the changes. You don't need a lot of workforce to work on the automation side. Any single person, 2 person, or 3 person is sufficient to work on and manage your even very big infrastructure. Standardized configuration is there. Collaboration, there's a lot of collaboration. You can manage your developer, various team members in a centralized way, right? So we will talk about community. It's a very strong community of the Terraform. So if any help needed, we can easily get it with the community forum or Terraform community forum. So community have is very important. You can get easily a lot of solutions on the community forum. So we will discuss about step by step. So some of the use cases let's talk about of the Terraform. So HashiCorp Terraform is an infrastructure as a code tool that lets you define infrastructure resources in human readable configuration file that we can version, reuse, and share it. Okay. You can then use a consistent workflow to safely and efficiently provision and manage your infrastructure throughout its life cycle. The first one is the use case is the multi-cloud deployment. You can provision infrastructure across multi-cloud, increases fault tolerance, allowing for a more graceful recovery from cloud provider outage. However, multi-cloud deployment add complexity because each provider has its own interface, tools, and workflows. Terraform lets you use the same workflow to manage multiple providers and handle across cloud dependencies. This simplifies management and orchestration for large scale multi cloud infrastructure. Application infrastructure deployment, scaling, and monitoring tool. So, you can use Terraform to efficiently deploy, release, scale, and monitor infrastructure for multi-tier application and tier application architecture. Lets you scale application component independently and provides a separation of concern. An application could consist of a pool of web servers that use a database tier with additional tier of for API server, caching servers, and routing messages. Terraform allows you to manage the resources in each tier together and automatically handles dependencies between tiers. For example, Terraform will deploy a database tier before provisioning to the web server that depends on it. So database will be it will make database ready before you deploying your web applications. So these kind of Terraform work and perform with the live scenarios. Self-service clusters. So at a large organization, the centralized, you can say centralized means you are in a house kind of things if you are developing, right? An operation team may get many repetitive infrastructure requests. You can use Terraform to build a self-service infrastructure model that lets product team manage their own infrastructure independently. So whenever they need, they just apply the commands and then they destroy it simply. So after testing, UAT testing, so this kind of dev environment they can create in your centralized environment, or you can say the private cloud. So we can create and use Terraform modules that codify the standard for deploying and managing services in your organization, allowing teams to efficiently deploy services in compliance with your organization's practice. Terraform Cloud can also integrate it with ticketing systems like ServiceNow to automatically generate new infrastructure requests as well. Moving to the next slide. So some more cases like policy, compliance, and management. Terraform also help us enforce policies on the type of resources teams can provision and use. Ticket-based reviews process or a bottleneck that can slow down development. Instead, you can use Sentinel, a policy as code framework, to automatically enforce compliance and governance policies before Terraform make infrastructure changes. Sentinel policies are available in Terraform Enterprise and Terraform Cloud version. Remember this. So I will talk about what is this open source and Terraform Enterprise and Cloud, Terraform Cloud as well. Okay, so PaaS application. So at platform as a service, as you know about, we don't need to manage a lot of infrastructure part as well. Okay, in the VM and operating system layers. But so this is giving example vendors like Heroku allow you to create web applications and attach add-ons such as database or email providers. Heroku can elastically scale the number of dynos or workers, but most non-trivial applications need many add-ons and external services. You can use Terraform to codify the setup required for Heroku applications. Configure DNS, DNS simple to set a CNAME and set up to Cloudflare as a content delivery network CDN of all the applications. Terraform can quickly and consistently do all of this without a web services. Software-defined networking. Terraform can interact with the software-defined network SDN to automatically configure the network according to the needs of the applications running in it. This lets you move from a ticket-based workflow to automated one and reducing the deployment time. Okay. So, and also we can use on the same way for the Kubernetes, parallel environment, and software demos. So Kubernetes is an open source workload, as you know, scheduled for containerization application. Terraform lets you both deploy in Kubernetes cluster and manage its resources like parse, deployment, or other services as well. You can also use the Kubernetes operator for Terraform to manage cloud and on-premise infrastructure through a Kubernetes custom resource definition, CRD and Terraform Cloud, right? So this is what it's all about. Okay, you can also deploy and UAT kind of testing on the for the software demos, QA, parallel environment you can manage. So Terraform is very efficient, guys, and this course is basically I'm focusing on very theoretical part, right? So first is the introduction part of this course, and we are going to talk about various part of the HashiCorp, offering HashiCorp. It's not all about Terraform only, right? But mainly focus on this course is on the Terraform, how Terraform is everything is work. So HashiCorp Terraform offerings, so infrastructure automation. So what the kind of certification is available right now? So there's three kind of, Terraform certified associate, Consul certified associate, and Vault certified associate. Vault means you are managing your secrets and everything, right? So infrastructure automation certification, we have two types. Terraform associate, this code is 003, and Terraform authoring and operational professional coming soon. So this is really mentioned this new course and things is coming soon for this particular offering of this HashiCorp Terraform course, right? Security automation certification, we have two types: Vault associate and Vault operational professional, right? Networking automation, Consul associate and Consul associate 002 is HashiCorp certified is kind of things is coming very soon. I mean, it's already there. So 002 and 003. Consul associate and Consul associate is two type of certification. I don't know why this is mentioned here, right? So these are the available of the certification with the HashiCorp auto certification side of, right? So if you want to prepare, you can go ahead with the certification and all. Installation version 1.74 content. This is the latest one version because I shooted this video very recently. So installing the Terraform. So I'm using a Mac OS, but you can go to the Terraform website directly. You can find the various installation part of this particular on-premises. You can say the standalone installation for them. So I'm using a Mac OS, so that's why I'm going to show you. Let me try this. If I can, I have a install or not. So Mac OS package manager. Brew is a tool. Tap HashiCorp. Brew install HashiCorp. Tap Terraform. So this is what we can use. So so this is the terminal basically I'm going to use. Let me little make this big. Okay, if you're able to see. I have to check version. So let me go. If this is my MacBook Pro. So I'm going to CD and documents, right? LS, and I'm going to, if any Terraform folder is created, yes, Terraform folder is created, CD, Terraform. So first you have to create your Terraform folder, right? LS, nothing, main.tf file is there. So I'm going to check what the version of Terraform I have. So Terraform -- version, I'm checking is installed or not. So it says the latest version is already up to date. But if it, you can see I already installed in my local machine, right? But if I am not installed, then we have to run this particular command to start installation on your current MacBook. Same way, you can go to the Terraform website, and you can start for you look for the Windows, Mac OS, Ubuntu, and everything. So I'm not going to discuss more on the installation part and all, okay? Because you can get easily get this information from the website directly. Okay, so next part is Terraform Associate. So this course is all I'm preparing for Terraform Associate kind of things. Okay, so this is what our focus is, right? The learning part. So standardize your deployment workflow, right? That's the first topic in this. So providers defining who is the what do you understand from the providers? So providers means AWS, Azure, Google, or Oracle platform, Docker, Kubernetes, or any other things. DigitalOcean, or you like a VMware. So provider define individual units of infrastructure. For example, is giving compute instances or private network as a resources. You can compose resources from different providers into reusable Terraform configuration called modules and manage them with a consistent language and workflows. So Terraform's configuration language is declarative, top to bottom, meaning that it describes the desired end state for infrastructure. In contrast, the procedural programming languages that require step-by-step instruction to perform the task. Terraform provides automatically calculated dependencies between resources to create or destroy them in a correct order. So to deploy infrastructure with Terraform, what are you going to do? You are a practitioner, right? Or maybe you're a developer, or you write written the code. So your infrastructure code is ready first. Then accordingly, you have to check the scope. Scope means identify the infrastructure for your project. What is your requirement and where is the requirement? Who is the provider? Where are you going to deploy? What services you need? What are the security policies you need? What are the infrastructure, different kind of resources you require? So this is what we have to think of. This is called scope. Right? What is your scope? Author, who is writing the configuration for your infrastructure, right? So this is the author, or you can say the practitioner, or you can say the IAC code developer, or it may be anyone. It may be like your cloud operation engineer, your DevOps guy, or maybe an architect is working on some IAC code, right? So if you're working in a service-based company, you have to do everything. They don't think you're an architect, you are a DevOps engineer or what. Okay, so you have to be ready for this. Initialize. So first, install the plugins of Terraform needs to manage the infrastructure as per your service provider, right? So automatically it will download those plugins in your in a particular folders, right? So next topic is comes the plan. So the plan basically, preview the changes Terraform will make to match your configuration. Exactly what you require, it will show you, right? What you're going to deploy. Same way, when you apply, make the plan changes. So when you apply, it will start the deployment. So after the deployment, whatever the service provider you choose, all the reference is taken from the HashiCorp website only. So it will go and deploy here on your particular infrastructure you chosen, right? So let's talk about the provider versions. Lock and upgrade provider versions. So Terraform provides manage resources by communicating between Terraform and target APIs. Whenever the target APIs change or add functionality, providers maintainer may update and version the providers. When multiple users or automation tools run the same Terraform configuration, they should all use the same version of their required providers. There are two ways for you to manage providers version in your configuration. Specify provider version constraint to your configuration Terraform block. Use the dependency log file. So this is what we have to little bit dig more on this, the dependency log file, right? Let's go to the Terraform Community Edition and Terraform Cloud Edition, and one more is the Enterprise Edition. Enterprise basically used by the various big organizations, so I'm not mentioned here because this is for the kind of R&D kind of course you learn, and accordingly you will get the access and all. So Terraform Cloud is a platform that you use you can use to manage and execute your Terraform projects. It includes feature like remote state and execution, structured plan output, and workspace resources, summaries, and more. Terraform Community Edition. So this is misspelling here. So community wise missing. Terraform version 1.1 installed locally and AWS account. This is the, for example, I mean, you can do it within your Azure with the local credentials configured for with their user to use the Terraform. Okay. So clone example is better. So first you need to create a folder just like I created here. If you can see in the example, I created this folder, right? Terraform folder, right? So this is the under this folder. I'm inside it, right? So and accordingly you have to clone your local machine if you want to take a backup, you can say, or you have to maintain your version control on the GitHub using GitHub or any other Bitbucket, whatever you want. You can use GitLab also. GitLab is a some different story, difference in built solution, services also. So I will make one course on the GitLab as well very soon. So review the configuration. So directory is a initialized Terraform project with three files: main.tf, terraform.df, and terraform.log.scl. So hidden file. If you don't know much about the hidden files and all, I'll already make on my YouTube channel for my Linux full courses for the professionals. So you go through it, all the courses, and check it, and you will learn first Linux on also on it. Okay, but it's not required mandatory. I mean, you can understand what is the hidden file and all. So HashiCorp has released newer version of the AWS provider since the workspace was first initiated, right? So think about it: main.tf file, terraform.tf file, and and a log SQL file. We have to work on these things very frequently, right? Now we have to little bit explore on the main.tf file. So open the main.tf file. Or you can just create a touch and create this, okay? So what is all about the main.tf file? This question we will ask in you many various interviews. What is the main.tf file in the Terraform? So what are you going to answer? This is the answer written in front of you. So main.tf file uses the AWS or any other service provider, random provider to deploy and randomly named kind of S3 bucket is talking about the one resources, right? Or you can say the services. S3 bucket to use first two reason. Okay. The main.tf file is a conventionally named file that serves as the main configuration file for your infrastructure. It's where you define and declare the primary resources, providers, variables, and other setting for your Terraform projects. So this is what the answer of this. What is the Terraform main.tf file? This is mostly asked questions in the DevOps and cloud interviews or in even a Terraform interviews. So main.tf file providers, this is the written in the block. So let's little bit understand what is the block is. So this is the provider AWS reason to start here, and it's in here with the curly braces. Reason your provider is US based to your whatever you're going to deploy. The service says it's deployed in the US based to, right? Resource random pet name length 5 or just as I'm taking the sample. So this is the one block, right? Start from here. This is the and same way resources it's start from here and it's giving all the information about this particular S3 bucket, right? And it will come here, right? So this is how it's closed, and this is where they start from here at the main file. Let's close this one. You can close it like this. Here, one close is here, and this one close is here. This one closes here. So this is another block. So we will talk about more on this in coming lectures. Okay. So let's talk about a little bit on the provider configuration. So what is the provider? So the provider block is used to configure the cloud provider or backend that Terraform will interact with. This is where you set up authentication details, your reason details, and other provider specific configuration. So suppose here is example shown here, provider AWS, reason is US West 2. Your access key, your secrets key, you can also mention over there, okay? Now we talk about the resource declaration. So resource or the building block of your infrastructure, the main.tf file, you declare the resources you want to create, such as instances, networks, or storage. Each resource has its own configuration block. So thus, the first block is written here, resource AWS instance. Example, AMI, as you can see, the same image and instance type is T2 micro. Even you can define more on this, so it will take automatically. So if you define T2.micro, T2.micro have some specific configuration already, and you can install. I mean, you can use you can directly use it, right? So this is what is about the resource declaration and the provider configuration. So I hope you remember these things. Okay, this is the very main part. Okay, so let's talk about a little bit on the data block. So what is the data block? The data blocks fetch information from the provider that can be used elsewhere in the configuration, commonly used for retrieving existing resources like DataWS MI, latest version, latest Amazon, Linux, most recent true, honors Amazon, filter names, and this is giving the details about this particular AMI images version. So this is the data blocks. So data, right? Variable declarations. How are you going to declare? So variable allows you to parameterize your configuration in main.tf file. You can declare variables or reference them from an external file as well. Same, you can develop a nested file of Terraform deployment. So variable is a stand count. Suppose description the number of instances to launch, type number, and default one. Okay, so this is how you can define the variable. Instance count. So instance count can be, suppose you are the same type of machine you want to deploy many things. So it will start creating a loop and kind of things. Okay. Same with the output blocks. So the output blocks define values that should be exposed after Terraform applies the configuration, useful for displaying important information or passing data between different Terraform configurations. So output instance public IP, value is AWS instead example.public IP. Including these element in your main.tf file gives Terraform the necessary information to plan, apply, and manage your infrastructure. The main.tf file is a central and crucial part of any Terraform projects. I written each and everything, guys, on the slide. So if you not able to hear me properly or not able to understand my voice or something, you can easily read these slides and I can learn about the Terraform. Now we have to explore terraform.tf file. Okay, so open that. So suppose we are going to open the terraform.tf file. Okay, and what is this inside it? So here Terraform block which specify the required provider version and required Terraform version for this configuration, right? So the Terraform, let me read about this. So the Terraform block contains the required providers block, which specify the provider local name, the source address, and the version. When you initialize this configuration, Terraform will download version 3.10 of the random provider. So if you want to work on the particular version, it would also give the option. The latest version of the AWS provider that is at greater than 2.00. The version constraint operator specifies the minimum provider version that is compatible with the configuration. So the Terraform block also specifies that only Terraform binaries newer than version 1.1x can run this configuration by using the less than is equal to operators as well. So you using here less than is equal to operator here, less than is equal to open here. Required version. Minimum, this is the requirement. Okay. Let's move to the next slide. Explore the terraform.log.scl. So this file is maintained automatically by Terraform init. Manual edit may be lost in future updates. So this is we have to think about it. So when you initialize a Terraform configuration for, the first time with the Terraform 1.1 or later, Terraform will generate a new Terraform log.scl file. In the current working directory, you should include the log file in your version control repository to ensure that Terraform uses the same provider version across your team and in infernal remote execution environment. So let me try this terraform init command. Okay, so this is my let me clear this. If I hope you're able to see. So I'm right here terraform init, initializing the backend, initializing the providing. So terraform has been successfully initialized. Let me see ls hyphen al. What do you see here? So main.tl file is created already. Dot, right? The hidden files. So if I do create main.tf file, nothing is there. Nothing is there, but yeah, now I have to, if I want to deploy something, I have to do more configuration. So this is what we will do later courses, right? So I was just showing you how it's initialize and do. So it's saying you may begin working with the Terraform, try running Terraform plan to see any changes that are required for your infrastructure. All Terraform commands should now work. If you ever set or change modules or backend configuration for Terraform, rerun this command to reinitialize your working directory. If you forget, other commands will detect it and remind you to do is so far necessary. So this is very important. We have to read these things. Okay. The screen means you are done. You don't need to read much on this. Okay. So this is what I run Terraform init command, right? Back to the slide. So notice the two providers specified in your terraform.tf file, the AWS provider version 2.40, and so if I write this kind of a script, so I mean, if I have to decide this log file, okay, but it's no longer the latest version of the disk provider. The random provider is set to version 3.10 and fulfill its version constraint. So you can see here directly. Rusty, this is the another block, H1, hash keys has been used by something. Provided is Terraform 3.1, and this is all the values. Next up is initialize and apply the configurations. I already showed you how you run the Terraform init command, and it will start initializing. This is how it looks like. Okay, so notice that instead of installing the latest version of the AWS provider that confirm with the configuration version constraint, Terraform install the version specific in the log file. While initializing your workspace, Terraform read the dependency log file and downloaded the specified version of the AWS and random providers. So this is what all about. Okay. If Terraform did not find a log file, it would download the latest version of for the providers that fulfill the version constraint. You will find the required provider block. So the following, this is the table created here where the Terraform would download in this scenario. So suppose your provider AWS. So version constraint is 2.00 and random 3.100. Terraform init, no log file, latest version is easy 4.450 or 3.10. Terraform init, log file version 2.50 and log file version 3.10. The log file instruct Terraform to always install the same provider version, ensuring that consistent run across your team or remote session. So this is what we use in mostly the organization kind of things. Okay. So apply your configuration. So you respond to the configuration prompt with a yes to create the example infrastructure. So I'm showing this example because we're going to a lot use in our coming lectures. Okay, so Terraform apply plan to add. So this is the example apply command. So two resources will are updated with your infrastructure. So upgrade the AWS provider. How are you going to upgrade this? So the hyphen upgrade flag will upgrade all providers to the latest version consistent within the version constraint about the function. So let's do this. So Terraform init hyphen upgrade command we have to use, right? So suppose I'm using Terraform init hyphen upgrade. So it's saying Terraform has been successfully initialized. You may now begin working with the Terraform. Try running Terraform plan to see any changes that are required to you. So Terraform, if plan I have applied here, what is this? So if such a measure the configuration, no changes, no changes required. So it don't know where what I'm doing. Okay, so nothing. I mean, I have not created anything. So this is what it's showing. Terraform has compared your real infrastructure against your configuration and found no differences. So no changes are needed, right? Okay, so tips, you can also use the upgrade flag to downgrade the provider version of the version constraint and modify to specify a lower version provider version. So Terraform apply when you use, it will start deployment. So this is what it's all about. Okay, so dot terraform.log.shell file and notice that the AWS provider version is now the latest version. So I have not did maintain any file, but I will show you in coming lectures for all this. We will talk in details. Okay. So for removing, so clean up your infrastructure. So what are you going to use to clean the infrastructure, whatever you're creating? So after verifying that the resources were deployed successfully, deploy them, destroy them. Remember to respond the confirmation prompt with yes. So, okay. So this is the example it's showing here. So Terraform destroy means it will destroy each and everything on the query cloud environment, right? So this is what I have to use. Do you really want to destroy all resources? You have to press yes and it will done. So this is the Terraform. So now you have to focus on the commands, the process only in this video. Okay. So if you want to learn more about the providers, visit the following resources. So dependency log file documents, you can search Google directly. Okay. And provider version consistent documentation calls API with the Terraform providers tutorials walk you through how providers serve as a bridge between Terraform and target APIs and shows you how to build a custom Terraform. So these are the basically the three links I shared here. If you want, I can also copy it in the video description video. So we'll go through these things and little bit you have to learn directly from the Terraform website. Okay. So, okay, so let's move to the next slide. Building infrastructure. So I recommend this topic is a different topic. So we will talk in details in our coming videos. Okay. So thanks for your time, guys, and have a nice day. And learn it, and please subscribe this channel, like it, because I'm creating a lot of videos in coming videos, and you will learn it free. You don't need to pay anywhere any money. Don't waste your money. Put your money in effort of learning and your certification. Okay. So thanks for your time. Have a nice day again. See you in my next video.